Okay, solving a system by elimination. So we talked about substitution. This is just another, and graphing. So this is just another way to solve. Not necessarily better than one way than the other. This one just sometimes is a little easier. If I already have two equations and they're already in standard form, which these two equations here are in standard form, sometimes using elimination is the best way to do it. Um, Elimination is pretty much what it sounds like. I'm going to eliminate something. So what I want to eliminate is either my x variable or my y variable. It doesn't matter which one. Again, it just kind of depends on which one is the easiest. So in this case, I'm going to notice here that my y's, I have a negative 6y and a positive 6y. So they're opposites. So if they're opposites of each other, then I'm going to be able to eliminate them a lot easier. So I'm going to take my two equations and I'm going to actually add them together. So I'm going to add my x's together. 5x plus 3x is 8x. Negative 6y plus 6y is actually 0y. And then my constants on the other side, negative 32 and plus positive 48 is going to be a positive 16. So notice I have 0y, so I don't really need that at all. And what I end up with here is 8x equals 16. I'm not quite done because I don't have x yet. So I'm going to divide both sides by 8, and x equals 2. Now, since we're solving a system, remember that means that I need a point for an answer. So all I have so far is my x value. This is our x value, right? And this is our y. So I don't have that other point yet, or the other part of my point. So I'm going to have to go back to my equation, and it doesn't matter which one. I don't know. I'm going to pick this one. So 3x plus 6y equals 48. And I'm going to take this 2 and I'm going to plug it in for that x. So 3 times 2 plus 6y equals 48. 3 times 2 is 6. Okay, then I'm going to subtract 6 from both sides. 6y equals, and then 48 minus 6 is 42. Divide both sides by 6, and y equals 7. So my solution is 2, 7. You have to do both parts in order to get that point because you got to have an x and a y. Okay, let's try this one. Again, I'm going to look for something that I can eliminate. So I'm noticing here that my x's, again, the x's this time are opposite of each other. So 6 and negative 6. So when I add that together, I actually get 0. I'm not actually going to write a 0x. You don't need to. They just eliminate. But negative 3y and positive 5y gives me a 2y. 3 plus 3 is 6. Divide both sides by 2. And y is 3. So now I'm going to come over here. I always like to make myself a spot where I write my solution just so I make sure I plug everything in properly. And this is a y, so not going to put it here, going to put it here, because that time I solved for y and not x. So it's not like you just, whatever the number you got first, you put in the first spot. If you solve for x, it goes in the first spot. If you solve for y, it goes in the second spot. Okay, now I'm going to have to go back again and substitute in to find what my x value is. So this is y. I'm going to sub in for y this time. So I'm going to put 3 in for y. 3 times 3 is 9. Whoops. Can't write and talk. I'm going to add 9 to both sides. 6x equals 12. Divide both sides by 6. And x equals 2. Put my 2 in there. And my solution is 2, 3. All right, so now let's look at how we might set up a word problem and solve it by elimination. So suppose your community sells a total of 292 tickets for a basketball game. An adult ticket costs $3. A student ticket costs $1. The sponsors collect $470 in ticket sales. Write and solve a system to find the number of each type of ticket sold. Now, there's two things two different equations we need. We know it's a system, so we know we're going to need two equations. Anytime you're dealing with money, there's two things that I always look for. I want to find an equation that has to do with quantity. I don't want to spell that all out. Quantity, and one that has to do with value. And that'll just kind of help you figure out what your two equations are. Quantity meaning the number, value meaning what it's worth. So if we're talking about money, the value is going to be something with the money, right? So a student ticket costs $1, an adult ticket costs $3. They collected $470, right? So that's all has to do with value. I also need to make sure that I define what my x and y are going to be. You can't just start solving an equation and not write down what x and y are, because they could be lots of different things. So I am going to say that x is number of adult tickets. Oh, adult tickets. Well, if that's the number of adult tickets, then that means y is going to be the number of student tickets. Okay? Now, quantity is the number. I got to know how many tickets I sold. Well, if I sold X adult tickets plus I sold Y student tickets, that would equal the total number of tickets I sold, which happens to be 292. So X plus Y equals 292. That's quantity, how many I sold. The other one is value. So now we got to talk about this ticket price. So adult tickets, I said they were, I sold X numbers of them, and they cost $3 a piece. So 3 times X, that's going to be the value, right? If I sold 5 tickets, that would be $15 I made. If I sold 10 tickets, I'd make $30, because you're going to multiply how many you sold, that's our variable, times how much they're worth, or their value. The same thing for Y. Now, kids' tickets are only $1, so 1Y. And I know that I sold $470 worth of tickets. All right, now, I noticed that both of these are 1s. However, they're both positive and they're not opposite of each other. So instead of adding the equations together, I'm going to subtract them. Now this is a little tricky, because if you're going to subtract an equation like this, it looks kind of like this, minus the whole entire equation. And now I've got something that looks a lot like distributing. I'm going to have to distribute that negative to all of these, which just means that it's going to change all of them to a negative. So 3, and then when I add, then x minus 3x is negative 2x. And now these are going to cancel. And 292 minus 470 equals negative 178. Divide both sides by negative 2, and x equals 89. So x is 89. So I could write it like this, 89. Whoops, there we go. There we go, 89, right? But I also kind of need to know what that means. So X represented the adult tickets. So what I sold was 89 adult tickets, right? Now I still need to know the student tickets, and I am definitely coming back to this equation, because that is a much easier equation, right? I know that X is 89 plus Y equals 292, so I can subtract 89 from both sides, and Y equals 292 minus 89 is 203, 203, or 203 student tickets. Okay? And this would be my appropriate answer. Since it's a word problem, we want to have labels. All right, let's try one more. Your class sells a total of 64 tickets to a play. A student ticket costs $1 and an adult ticket costs $2.50. Your class collects $109 in total ticket sales. How many adult tickets did you sell? How many student tickets did you sell? Okay, same thing. I got quantity and value. So I think I'll just stick with this adult, number of adult tickets, and then number of student tickets. Gonna have to write my equation for quantity and my equation for value. Quantity would be x plus y equals, and how many tickets did we sell? 64. And then my value, my adult tickets cost $2.50, so 2.5x plus y because they only cost $1, and I sold 109, right? And again, since my y's here are similar but they're not opposite, I'm going to subtract this time instead of adding, which means when I distribute, everything here is going to get a negative. So when I add my y and my negative y, I'll eliminate those. But when I add my x's, I get negative 1.5x. And then 64 minus 109 gives me negative 45. And divide by negative 1.5. Divide by negative 1.5. And I get x is 30. So I have 30 adult tickets. And x plus y equals 64. So if x is, x was 30 plus y equals 64. So minus 30 and minus 30. Y equals 34. So 34, were they student? Yeah, student tickets. Student tickets. And that is elimination by addition and subtraction.